Hello one and all, and welcome to the Math Magic Show. I'm going to show you how to find the antiderivative of this crazy looking function. Please be sure though to check out Kayla's video on the opposite of this, which is differentiating, to get back from step 9 basically to step 1. It's linked down below, but also in the cards. So please be sure to click and check out her video. She's new to the channel, recently graduated from Columbia University with a degree in math and economics, so you know you're in good hands. Anyway, let's take a look. We have the following antiderivative of 1 over 3, and then it's the cube root of x to the 4th, plus 2/3, and then the cube root of x. Now, take a look. Anything in blue means it's changed relative to the previous step. So I'm rewriting the 3 and the 4 as 4/3, exponential form, and I'm writing this cube root here as 1/3, an exponential form. Now, take a look. At the next stage, the antiderivative becomes the antiderivative of 1 over 3, keep the negative, and then write that 4/3 as negative 4/3 by the rules of negative exponents, plus 2/3 and then x to the negative 1/3, again by the rules of negative exponents. Now what you can do at step 4, when you go from 3 to 4, is apply the power rule for integrals. So it's x to the n plus 1 over n plus 1 plus the c. I'll attach the c at the very end just to not have to write it. It's too much clutter, do you know what I mean? Anyway, so that's that. Let's take a look, friends. So now, take a look at the next stage. Negative 1/3 x raised to the negative 4/3, and you have to attach the 1, so plus 1 up here. 1 divided by negative 4/3 plus 1. Again, blue means it's the last thing changed relative to the previous step. Otherwise, it's hard to see what's happening when you have so many steps. Same thing over here. You're going to have originally 2/3 x to the negative 1/3, so now it becomes 2/3 x to the negative 1/3 plus 1. Divided by negative 1/3 plus 1 right here, applying the power rule. In this case, it happens like in this example right here. The power, well, for the power rule, n is, let's see, negative 4/3, and for the second part, n is negative 1/3 right here. See, negative 1/3. All right, let's go on to step 5. So what I'm doing relative to step 4 and step 5 is, notice this says 3 over 3, so the 1 has been written as 3 over 3. The one in the bottom here where I'm pointing, that's been written as 3 over 3. This one right here, that's been written as 3 over 3. And this one right here has been written as 3 over 3, this way. Okay, so we have step 5 thus far. What we have to do now is add up all the fractions. There's a crazy number of them. Actually not, right? It's only 1, 2, 3, 4 fractions. Let's be careful. Keep the negative 1/3. Then you have negative 4 plus 3, which is negative 1/3 right here, this fraction where I'm pointing. On the bottom, negative 4 plus 3 is going to be negative 1/3 in blue, you see? Look at this one. Negative 1 plus 3, that's going to give you positive 2/3 up here. Negative 1/3 plus 3/3 is going to give you positive 2/3 right here. When you transition from 6 to 7, look what happens carefully. This negative 1/3 comes up here as negative 3/1, or 3 over 1 rather, times x to the negative 1/3 plus 2/3. And that 2/3 comes up here now as 3/2. Again, blue means it's what's changed relative to the previous step, so you can keep track. And then you copy the x to the 2/3, that hasn't changed. Step 8, well, this 3 cancels with this, and then this negative will cancel with this negative. Here, this 2 cancels with that, the 3 cancels with the 3. So that means when you go from 8 to 9, we have the negative with the negative, that's going to give you a positive. So that positive really should be in blue, but you get the idea by now. And this is then x to the negative 1/3 plus, and what's left over here is just x to the positive 2/3, and then you can attach the c at the very end. As you can see, these kinds of questions, are they really complex? Are they hard? I don't know, it depends. You see, if you're really good with fractions, then it's not too bad. It's very formulaic and mechanical. So as long as you know the rules of fractions, you can go from 1 to 9 in a relatively reasonable amount of time. But if you don't know the rules of fractions well, it can be a bit tricky, right? And it can seem very hard, in fact, I would say. Well, that is it for this one. Again, please be sure to check out Kayla's video. It's linked in the card in the description down below. She shows you how to go basically from step 9 back to step 1 to a differentiation. So from 1 to 9, integration. From 9 back to 1, differentiation. Those two processes are reverses of each other in that sense, you see. I'm going to leave it here though, so please leave a like, please subscribe. Please be sure to leave some comments down below and suggestions for future videos. If you need another example like this, please type it up in the comments down below. And I will see you in the next video.